In this video, let's look on to the HC-SR501 PIR sensor or passive infrared sensor, which act as a motion detection sensor. Let's see how we could interface it with a relay module and an Arduino to make a lamp light whenever a motion is detected. So in this image is the HC-SR501 PIR sensor. So from this website, courtesy from that website. So let's focus on these three pin header first. One, of course, we have the pins for the power. One is for the VCC, one is for the ground. So in this case, we want this to interface with the Arduino. The VCC is connected to the 5 volts of the Arduino, and the ground of this motion sensor is connected to the ground of the Arduino. And uh, this HCSR501 has an output signal uh, of 3.3 voltage logic. Uh, it outputs 1 whenever there's a motion detected and 0 if none. So this one is connected to the pin D2 of the Arduino, and right here are the trigger pins. So usually they have there's a jumper uh, in default with the non-repeatable trigger. So uh, in my opinion, I think it's better with this one, the other side, which is the repeatable trigger mode, because you'll see it later why I choose that. So in my configuration, I put the jumper here uh, on the repeatable trigger, and here some kind of a dial or potentiometer. This one is for the distance adjust. Basically, you can tweak the sensitivity of the distance wherein the motion sensor reacts. So this ranges from the maximum of 7 meters, I guess, yes. And the delay time is the ranges from 0.3 seconds to 5 minutes. So in my configuration, uh, I dialed up this potentiometer all the way to its minimum, uh, uh, counterclockwise, and the time we 0.3 seconds is sufficient. So I dialed it down. So yeah, that's my configuration. So this is the schematic. As you can see, it's quite similar to the previous videos project, the Bluetooth controlled lamp. But in this case, this is controlled with the motion detection. Whenever there is a motion, the lamp will light. So here we have the HC-SR501 motion detection sensor. It has 3 pin heads. One is connected to the ground of the Arduino. Other one is the VCC connected to 5 volts of the Arduino, and its output signal is connected to the pin 2 of the Arduino. And as of our relay module here, since we only control one device, so we only need this channel, only one channel, and its input 1 is connected to the pin 3 of the Arduino, and the VCC is connected to the 5 volts of the Arduino. So as I've mentioned from the previous video, uh, there's no connection for ground here because this is to further implement optical isolation, because the ground of the another external power supply, or let's say a charger, 5-volt charger, is sufficient, and we really need isolation of different power sources that is connected in the relay module. So uh, And again, as I mentioned, you need another power supply to energize the coils of the relay module, a 5 volt power supply. And uh, we have here the lamp. It is controlled with the AC source. It is powered with the AC source, and it is connected. Its other wire is stripped down to the normally open uh, connection. So that's it. And the again, the HC-SR501 is configured to repeatable mode, and its sensitivity or distance sensitivity potentiometer is dialed down or to its minimum, and as well as the delay time. So here is a simple code. First, we define PIR sensor at pin 2, relay input at pin 3, and under our void setup, we declare PIR sensor as input and relay input as output. And under this line, we have a 60,000 microseconds delay or 1 minute delay to stabilize the sensor, because under that first 60 seconds, the reading is quite unstable, and this simply means that the PIR sensor is still adjusting with the environment. And under a void loop, we declared sensor value, reading the value of the PIR sensor. Basically, this will return 1 if there is a motion detected in the PIR, and 0 otherwise. So this is the condition. If there is a motion detection, sensor value becomes 1, and we set low to the relay input because logic low will activate the relay. It works inversely the relay, and else is we write it high. That's basically it. After the Arduino boots up, it starts the 60 seconds delay to give the PIR sensor some time to stabilize. And also, initially, our lamp lights up. This is because we set pin 3 as an output and with initial state of low. That's why it lights up. And after 60 seconds, our lamp lights off, and I wave my hand near the PIR sensor to see if it responds and lights on the lamp. It works. There you have it, a motion triggered lamp.